Here we're going to look at solving inequalities. Now this historically has given gives a lot of kids some issues because they find these inequality symbols very uncomfortable. So before we jump into these, let's step back and remind ourselves, if I were solving an equation like x minus 2 equals 5, and I'm in algebra, this is back in like algebra 1. You add 2 to both sides, you get x equals 7, and that's it, right? You're done. The answer is x equals 7. That is the equation. That is the number that makes this equation true, and it's the only one. And inequality is different because you don't get one answer. So if I do x minus 2 is bigger than 5, we can proceed the same way as though it's an equation, and we get x is bigger than 7. But the idea, though, is that, yes, this is the solution, but this is not representing one number. It's representing an infinite number of numbers. It's representing all the numbers that are bigger than 7. All the numbers that are bigger than 7 make this inequality true. And if you look on the graph, you did these back in algebra 1, what you would do is you'd put 7 on the number line. You'd probably put an open circle because x can't equal 7, but it can be any number bigger than 7. So you'd shade that way. Any of these numbers over here work, and that's why this is the solution. This is the graph of the solution. The graph of the solution x equals 7 would just be the number line with the number 7 filled in as a dot. Like that would be the only answer. Okay, so in an inequality, you don't get one answer. You get a whole range of answers. If you get a set of answers. Okay, so we're going to solve this inequality for x. So again, you want to proceed as though this is an equal sign, at least in the algebra sense. So what we want to do is we actually want to, pretend in your head that this is like x squared minus 5x equals 6. If it was equals 6, then you would know, hopefully, that we want to set it equal to 0. And that is still the case with inequalities. Okay, getting 0 on one side is important because it allows us to state or make very clear comparisons in terms of the values of our function. Okay, so that's still the first step. The other thing that doesn't change is you'd want to factor this. So we're going to factor this. Okay, so again, notice nothing's really changed in terms of how I'm proceeding. I'm just kind of copying down the inequality symbol instead of the equal sign. So this factors, I think, into x minus 6 and x plus 1. Now here's where it differs. If this was an equation, we would say our answer is x equals negative 1 and x equals 6. But it's not. It's an inequality. It's an inequality, and we want to know when is this expression here bigger than or equal to 0. So we're going to use a number line to gather our answers. So you'll notice that in this section, this unit, number lines play a very key role, and that's because they're helpful in sort of getting all your information in one place. So the zeros are negative 1 and 6. So that's a 0, and that's a 0. And we do what we've done before, which is we plug in values that are in between our zeros and outside of our zeros to determine if this expression is positive or negative in those places. So for instance, I'll plug in negative 2 because it's over to the left. Negative 2 plus 1 is a negative. Negative 2 minus 6 is a negative. And a negative times a negative is a positive. Plug in 0 because 0 is in between negative 1 and 6. 0 plus 1 is positive. 0 minus 6 is negative. And a positive times a negative is a negative. And then 7. 7 plus 1 is a positive. 7 minus 6 is a positive. So now that we have our number line, we actually are ready to answer the question. We want to know when this is bigger than or equal to 0. So I know we kind of, if you notice, the answers, just like up here, the answers to the answer in the end, when you plug it back into the original equation, it makes the equation true. The answers we get here are all going to work for the original inequality as well. Even though we morphed it to look like this, the idea is still that the answers, the x values that are true here are also going to be true here. So when is this expression bigger than or equal to 0? That means we're looking for the intervals that have the pluses above them. So our answer is going to be negative infinity to -1. And I'm going to put a hard bracket on the -1 because we want when the function is bigger than or equal to 0. So it can equal 0. We want those answers too. We want those x values as well. Union, and then from 6 to infinity. Hard bracket on the 6. There is the answer. Okay, notice it's an interval of answers. It's a range of x values, or it's not just one x value. Any of the answers, any of the values less than -1, including -1, are bigger than 6, including 6 work. Just to connect this to the graph, notice that if we graphed x squared minus 5x minus 6, we would get a function that looks like this. You don't have to do this. I'm just trying to connect this to what we got. So notice the y values are positive here and here, and obviously equal to 0 at those places. So we can sort of, and that's where our function is bigger than or equal to 0 here, and also here. Okay, so that we capture all that information without having to graph it, just by using a number line analysis. Let's do this next one quickly because the process is no different. It's just that it's a rational function. So x squared plus 2x minus 3 divided by x squared plus 8x plus 15. When is that less than 0? So again, we could graph this and just look at the graph, but we can also get the answer to the inequality more quickly if we use our number line method. So I'm going to first factor the top. That doesn't change. So that's x plus 3x minus 1. In the bottom, I'm going to factor x plus 3 and x plus 5. Okay, and so now notice that the x plus 3's divide, which means that I have a hole at x equals -3. Again, so we're viewing this like very much as a graph that has a hole in there, a hole at x equals -3. And what do I have left? So I'm going to copy down the final version of this inequality. What's left is x minus 1 divided by x plus 5 is less than 0. And now look at what we have left. We've got a rational expression, and the 0 of the denominator is -5. That means I have a vertical asymptote. And I have a 0 at 1. And all these things I'm going to put on my number line. I'll use the good number line here now. Okay, so I'm going to put -5 on my number line. I'm going to put vertical asymptote above it, or VA, to remind myself it's a vertical asymptote. I'm going to put a -3 and an H to remind myself there's a hole there, and then a 1 and a Z above it to remind myself there's a 0 there. All this, again, we're getting all this on the number line, even though we don't have the graph in front of us. We don't really need it. But we do need to identify what those x values are actually at those points. So now we plug in a value to the left of negative 5. So negative 6 is negative 6 over, negative 6 minus 1 is a negative, divided by negative 6 plus 5 is a negative. It's a negative divided by a negative is a positive. Negative 5, a number in between negative 5 and negative 3, how about negative 4? Negative 4 minus 1 is a negative, divided by negative 4 plus 5 is a positive, and negative divided by a positive is a negative. 0 is in that interval. 0 minus 1 is a negative. 0 plus 5 is a positive. 0 divided by negative divided by positive is a negative. And I'll plug in, 10. 10 minus 1 is positive, and 10 plus 5 is a positive. So that's a positive divided by a positive. Okay, so now I have my number line. I just need to analyze it correctly and focus on what the answers. Focus on the section that is going to give me my answers. I want to know when this graph is less than 0. It's less than 0 on the intervals that have the negatives. So my answer is going to be negative 5. And notice I'm not going to include negative 5 for a couple of reasons. One is there's a vertical asymptote there, so there's no value there. So the function isn't less than 0 there. The function doesn't exist at negative 5. So negative 5 to negative 3. And then there's a hole. So I got to jump over that hole. And then the function is continuing to be negative between negative 3 and 1. And this is the answer. Okay, notice once you have the number line, you can answer all possible variations of this. If I wrote instead bigger than or equal to 0 here, we would do everything exactly the same. It's just that our final interpretation of our number line would determine what we write over here. Okay, so regardless of what the inequality is doing, the process is always the same. But just keep in mind your answer is on our intervals, not particular x values.